Section 1.5, Quadratics. Our objectives are 1. Recognize and use the following forms of quadratic functions. A. Standard form, and B. Transformation form. 2. Identify and calculate the vertex and interpret the vertex of an application. 3. Find intercepts and interpret in the context of an application. 4. Know and use the quadratic formula. Quadratics are transformations of our toolbox function f of x equals x squared. Standard form of a quadratic function is f of x equals ax squared plus bx plus c with a vertex at an input value of negative b over 2a, which you then sub into the function to find the output value. Transformation form, also called vertex form, is f of x equals a times the quantity x minus h squared plus k with vertex hk. Make sure you pay attention to the negative sign here. So your h is the opposite sign of what you see in the transformation form of a quadratic function. Let's take a look at writing functions from graphs. Write an equation of the graph as a transformation of f of x equals x squared. So we're going to use the transformation form here. If I look at the graph, I can identify the vertex at the point negative 2, negative 3. So in the transformation form, I've already got most of it here. I just need the a. I want to look at two different ways to solve this. If you consider your basic toolkit function f of x equals x squared, we know that the vertex is at 0, 0. If we go 1 unit to the right, then our f of x would also be 1, so 1 unit up. If we go 2 units to the right, so x is 2, then f of x would be 4. So up 4 from the vertex. If I go 3 to the right from the vertex, so x equals 3, f of x would be 9. Now, when I look at this function here, when I go 1 unit to the right, it is less than 2 up. When I go 2 units to the right, it is exactly 2 units up instead of 4. So if we just keep track of these from our new function, so to right, we go up 2. That's half of 4 from the basic toolkit function. So that leads me to hypothesize that if I go 3 right, I would go 4.5 up. Let's check it out. 1, 2, 3 right, 1, 2, 3, 4, and then some. It looks like that's right. So I hypothesize that A is a half. Now, as you all learned when you first learned how to graph, you can only tell an exact point if you land somewhere where you are at integer coordinates. Let's look at solving for A algebraically. If I substitute in the vertex into my preliminary function here, I'm going to get negative 2 plus 2 is 0. A times 0, I'm not going to be able to solve. But if I sub in another point, I can solve for A. So let's use this point here at x is 0 and f of x is negative 1. Sub into here, and then we can solve for A. So f of x, negative 1, is A times 0 plus 2, quantity squared, minus 3. So negative 1 is 4A minus 3. So adding 3 to both sides, 2 is 4A. And dividing both sides by 4, A is a half, as we hypothesized. So we now have our function in transformation form. Now let's find the intercepts algebraically and using the calculator. If you look at the function itself, we know that the y-intercept is where x equals 0. So if I substitute in a value of 0 here, and I want to find the f of x coordinate for the f of x intercept, we can see at this graph that it is negative 1. But notice if we sub in the value 0, I have 2 squared, that's 4. Half of 4, that's 2. 2 minus 3, that's negative 1. So our f of x intercept at the point 0, negative 1 is correct from our inspection. Now when I look at the x-intercepts, I'm not going to be able to determine them precisely from this graph. It looks like about half, but I can't be sure. If I wanted to solve for them algebraically, it would look something like this. 0 equals 1/2 x plus 2 squared minus 3. 3 equals 1/2 x plus 2 quantity squared. 3 equals 1/2 x squared plus 4x plus 4. 3 equals 1/2 x squared plus 2x plus 2. I can multiply this whole thing by 2, and 6 equals x squared plus 4x plus 4. So 0 equals x squared plus 4x minus 2, and I can factor and it's not solvable by factoring. So what can I use? This is where the quadratic formula can come in handy. So to use the quadratic formula, I need to have my function in standard form. So let's first get the function in standard form. So here I'm solving for when f of x is 0 to find the value of these intercepts here. And I'm going to multiply the whole equation by 2. So 0 equals x plus 2 quantity squared minus 6. So 0 equals x squared plus 4x plus 4 minus 6. So 0 equals x squared plus 4x minus 2. Exactly the same place we were at here. So my A is 1, my B is 4, my C is negative 2. And now we're going to sub into the quadratic formula, which is x will equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's sub in our values here. And that gives me x is negative 4 plus or minus the square root of positive 4 squared minus 4 times 1 times negative 2 all over 2. So negative 4 plus or minus the square root of 16 plus 8 over 2. So negative 4 plus or minus the square root of 24 over 2. So that would be negative 4 plus or minus. Notice that 4 I can pull out as a 2 here. So negative 4 plus or minus 2 times the square root of 6 over 2. And I can simplify that one more step. Negative 2 plus or minus the square root of 6. So algebraically, we've just found the x-coordinates of the intercepts. So that would be the point 2 plus square root of 6, 0, and the point negative 2 plus square root of 6, 0, and negative 2 minus the square root of 6, 0. Let's now look at finding these intercepts on our calculator. So if I put in to the y equals our function 1/2 quantity x minus 2 squared minus 3, I can look at the graph, and it sure looks like our graph. It does not. What's wrong? Oh yeah, that was a plus 2. Okay, now let's look at the graph. Exactly where we wanted it to be. Let's find the intercepts. And we're going to find that using second calc, that second the trace button. These are called zeros. So they're also called roots. The intercepts are the zeros or the roots. I hit enter, and this is saying what's the left boundary of the 0 I'm looking for. So right now I can see that y is negative 1, so I'm going to go say this is the left boundary, and I'm going to go till I'm past and I get a positive y. That's the right bound guess, and it tells me this is the point x equals 0.4495. We're approximating a little bit. And let's do it again for the other one. So second calc 0. We want to arrow over till the cursor is close. So I'm at a negative value of y, hit enter. Arrow over till I'm at a positive value of y, hit enter. At guess, just hit enter. And something is out of bounds, so let's try again. Second calc 0. Left bound. So I need to be in positive territory first on the y values. So I've got a positive y here, hit enter. Right bound. Arrow over till I'm at a negative boundary, hit enter. Guess, hit enter. And there's my value, negative 4.4495. We'll estimate that one. And if we check these values against these points, we will see that they are indeed the same thing. So negative 2 plus the square root of 6 is indeed 0.4495 approximately, and negative 2 minus the square root of 6 is approximately negative 4.4495. Let's look at an application now. Note, if the quadratic formula yields complex numbers, that is, if we end up with a negative number under the square root, so we'll have an imaginary part, then there are no horizontal intercepts. Let's look at an application example. A javelin is thrown in the air where x is the horizontal distance in feet from the point at which the javelin is thrown. Its height is given by the quadratic function h of x equals negative 1/20 x squared plus 8x plus 6. How high is the javelin when it is thrown? When it is thrown would be the initial condition, that is where we start. That would be where x is 0. So if I substitute zeros in and find h evaluated at 0, so 0, 0, that would be 6 feet. When the javelin is first thrown, it's 6 feet above the ground. What is the maximum height of the javelin? If we look at the quadratic function for the height of the javelin, we see that we have a negative coefficient on the squared term. That tells us that our graph is going to look something like that. So the maximum has to occur here at the vertex. For a quadratic, the max or the min always occur at the vertex. So we're going to need to find the vertex to find the maximum height. Recall we had a formula. If we have our function in standard form, then we have a formula for the vertex, negative b over 2a, and then we would evaluate our function at that input to find the vertical coordinate of the vertex. So what is the maximum height of the javelin? Let's find the vertex. So when we look here, we're in standard form. Our a is negative 1/20. our B is 8, and our C is 6. So to find the vertex, we're looking for the x-coordinate of the vertex. That would be negative 8 over 2 times negative 1/20th. So negative 8 over negative 1/10. And recall that when you're dividing by a fraction, that's the same as multiplying by the reciprocal. So our x-coordinate is going to be 80. So that is the maximum occurs where x is 80 feet from where it was thrown. And our function here is h. So h of 80 would be the vertical coordinate of the vertex. We sub that in. And that's going to give us 326 feet. So now we have the vertex. How far from the thrower does the javelin strike the ground? The javelin is going to strike the ground where the height above the ground is 0. So where h of x equals 0. So that tells us we're looking at 0 equals negative 1/20th x squared plus 8x plus 6. If we solve for x, then we're going to have these 2 points here. So remember, here's where our graph is. When we hit the ground, that is h of x equals 0. Here's our vertex. This point here is our intercept, which occurs at the point 0, 6. So we can try and factor this. Not going to work. So we want to solve. Again, we want to use the quadratic formula. Now, to make things easy on ourselves, we may want to initially multiply both sides of our equation here by negative 20, and that would give us 0 equals x squared minus 160x minus 120. We want to solve for this. Now we've got an a equal to 1, a b equal to negative 160, and a c equal to negative 120. So we want to substitute in to the quadratic formula to find that value of x. So negative b plus or minus the square root of b squared minus 4 times a times c. I want to caution you when you're entering this into your calculator, when you are squaring a negative number, make sure that you have these parentheses, or the calculator is going to think that you're asking for this, which would be 160 squared, take the negative, as opposed to this. And I know that's a rookie error that you guys have probably figured out a long time ago, and this is supposed to say not equal. I realize it kind of looked like a plus or minus. All over 2 and you will find that you get two solutions. And I'm going to round here, so 161 and 24 hundredths and negative 1 point and 24 hundredths. And we can see this 0, if we look at our graph, that would be over here, which is not meaningful in our model, and the number we're looking for is right there. And that is the maximum. That is how far the thrower is when the javelin strikes the ground. You can also use your calculator to double check your answer there. You'll have to play around with the window a little bit to get it to show, but I encourage you to try that.